For millennia, men had grappled with the idea of an infinite past and the question of whether there was a beginning of the universe. Ancient Greek philosophers believed that matter was necessary and uncreated, and therefore eternal. God may be responsible for introducing order into the cosmos, but he did not create the universe itself. This Greek thought opposed ancient Hebrew writers who believed that the universe has not always existed but was created by God some point in the past. As the first verse in the Hebrew Holy Scripture states, "In the beginning, God created the heavens and the earth." Genesis 1:1. This debate was joined in by Muslim theologians as well, and one of them was Al-Ghazali, a 12th century Muslim theologian from Persia, modern-day Iran. He has been acclaimed the proof of Islam, the ornament of faith, and the renewer of religion. He was concerned that Muslim philosophers of his day were influenced by ancient Greek philosophy to deny God's creation of the universe, and after studying the works of these philosophers, Ghazali wrote a book called Tahafutul Falsafa, also known as Incoherence of the Philosophers, where he said that the idea of a beginningless universe is absurd. The universe, according to Ghazali, must have had a beginning, and since nothing begins to exist without a cause, there must be a transcendent creator of the universe. He formulated his argument as follows. Whatever begins to exist has a cause of its beginning. The universe began to exist, therefore the universe has a cause for its beginning. There's support for premise 1, which is whatever begins to exist has a cause of its beginning. And among these supporting arguments includes something cannot come from nothing. To claim that something can come out of nothing is worse than magic. When a magician pulls a rabbit out of a hat, at least you have the magician and the hat. The rabbit may have come out of nothing, but at least this coming out of nothing had a determinant or an agent, which was the magician. Secondly, if something can come into being from nothing, then why doesn't anything or everything just come into being from nothing? Why doesn't a horse or a teacup, for example, come into existence out of nothing today? Why is it only universes that can come out of nothing? What makes nothingness so discriminatory? There can't be anything about nothing that favors universes, as nothingness doesn't have any properties. Nor can anything constrain nothingness, since there isn't anything to be constrained. Thirdly and lastly, common experience and scientific experience confirm the truth of premise 1. Nobody committed to modern science can deny premise 1. Now a more controversial premise is premise 2, that the universe began to exist. Let's review the support for premise 2. Ghazali presents this philosophical argument to illustrate how the universe indeed began to exist. He says, "Any actual infinite cannot exist. An infinite temporal regress of events is an actual infinite. Therefore, an infinite temporal regress of events cannot exist, and the universe therefore began to exist." Ghazali argued that if the universe never began to exist, then there has been an infinite number of past events prior to today. But an infinite number of things cannot exist, he argued. Ghazali believed that a potentially infinite number of things could exist, but denied that an actually infinite number of things could exist. A potential infinite could be finite quantities, increasing towards an unreachable ideal limit, but never really reaching infinity. For example, you can divide a given distance into halves, then fourths, eighths, sixteenths, and so on, but there can never be an infinite number of divisions. But Ghazali argued that if an actually infinite number of things could exist, many absurdities would result. For example, John Philoponus summarized these absurdities in 3 main ways. Philoponus said that an actual infinity cannot exist, so the world must have a beginning. This is because the past would not be completed and that the future would never be reached. Secondly, Philoponus stated that the past must have a beginning, since the past is continually increased and infinity cannot be possibly increased. Thirdly, Philoponus stated that since planets move at different speeds, an infinity would include the absurdity of one's infinity being a multiple of another. This third example reminds of Al-Ghazali's rotating planets example. Al-Ghazali's example of rotating planets includes a thought experiment of rotating planets in an eternal universe, which take different times to complete a rotation. Planet A takes 1 year to complete a rotation, while planet B takes 30 years. If one were to divide the number of rotation years of planet A by planet B, one should expect 2 mathematical answers. One answer is 1 by 30 and the other answer is infinity, which clearly constitutes a contradiction. Now the thing is that I'm in my university right now and I'm having a lunch break during which I'm recording this, and so you'll be hearing some kind of noise, for which I apologize. Now, coming back to the point, the 14th century Jewish philosopher Gersonides puts this another way, saying, if the universe was eternal, the number of lunar eclipses would be infinite, which means that the moon would be in a state of eternal eclipse, which is absurd. Zeno's dichotomy paradox also illustrates the absurdity of an actual infinity. It is designed to prove that an object never reaches the end. Any moving object must reach halfway on a course before it reaches the end, and because there are an infinite number of halfway points, a moving object never reaches the end in a finite time. These absurdities, which result from the existence of an actually infinite number of things, could also be illustrated by the Hilbert's hotel example, which is the brainchild of the German mathematician David Hilbert. David invites us to imagine an ordinary hotel with a finite number of rooms. Suppose that all the rooms are full, and if a guest shows up at the front desk looking for a room, the manager says, "Sorry, all the rooms are full," and that's the end of the story. But now imagine a hotel with an infinite number of rooms, and suppose that all the infinite number of rooms in this hotel are full. Now suppose that a new guest shows up at the front desk looking for a room. What the manager does is that he moves the person staying in room 1 to room 2, the person staying in room 2 to room 3, the person staying in room 3 to room 4, and so on, so that the first room is now vacant and can be taken by the new guest. But before the new guest arrived, all the rooms were full, which is absurd. Now imagine that an infinity of new guests shows up at the front desk looking for an infinite number of rooms. What the manager now does is that he moves the person staying in room 1 to room 2, the person staying in room 2 to room 4, the person staying in room 3 to room 6, and so on, each time moving the person into the room number twice his own, since any number multiplied by 2 is an even number, and so all the odd numbered rooms become vacant. And the infinite number of new guests can be accommodated in these odd numbered rooms, and this can be done an infinite number of times to accommodate an infinite number of guests. But this is absurd, because before they arrived, all the rooms were already full. Hilbert's hotel is really absurd and can be generalized to show that the existence of an actually infinite number of things is indeed absurd. Ghazali presents another philosophical argument regarding the impossibility of forming an actual infinite by successive addition. He says, a collection formed by successive addition cannot be an actual infinite. The temporal series of events is a collection formed by successive addition. Therefore, the temporal series of events cannot be an actual infinite. The series of past events has been formed by adding one event after another, like a sequence of dominoes falling one after another until the last domino, which is today, the present moment. But, he argues, no series which is formed by adding one member after another can be actually infinite, for it cannot pass through an infinite number of elements one at a time. This is easy to see in the case of trying to count to infinity. No matter how high you count, there is still an infinity of numbers left to count. But if you cannot count to infinity, how could you count down from infinity? This could be like claiming to have counted down all the negative numbers all the way down to 0. This seems impossible, for before one could count 0, one would have to count -1, -2, -3, and all the way back to infinity. Before any number could be counted, an infinity of numbers would have to be counted first. You just get driven back and back into the past, so that no number could ever be counted. And so the final domino could never fall if an infinite number of dominoes had to fall first, so that the present day could never be reached. But obviously here we are. So this shows that the series of past events must be finite and must have a beginning. Alexander Pruss and Robert Koons also showed the absurdity of an actual infinity, illustrated in what is known as the Grim Reaper paradox, which is similar to Benedard's paradox, which only strengthen Ghazali's argument for the impossibility of an actual infinite. Now that we have established that an actual infinite cannot exist, let's address other questions that arise. There's this philosophical argument which begins by positing a disjunction. The first event to arise in the absolutely still and eternal universe was either caused or not. Consider the first disjunct, that it was caused. Either the necessary and sufficient conditions giving rise to this first event were eternally present or not. But if these determinant conditions were eternally present, then their effect would also be eternally present, which makes the existence of a first event impossible. On the other hand, if the necessary and sufficient conditions for the first event were not eternally present in the universe, then these determinate conditions themselves had to arrive in the universe, and we have only succeeded in pushing the temporal regress of events back one more event in the past. But we have already proved that the temporal regress of events cannot be actually infinite, because an actually infinite cannot exist. So one must stop at a first event whose determinate conditions did not themselves arise but always existed. But this has already been shown to be impossible. Therefore, the first event to arise in the universe could not be caused. But that forces us over to the second disjunct, that the first event was uncaused. While this is logically possible, it does not seem very reasonable, for this means that this event occurred entirely without determinate conditions for its happening. The universe existed in a static, absolutely immobile state from eternity. Then, inexplicably, without any conditions whatsoever, a first event occurred. Such a theory seems inherently implausible, as Zwart observes. This leaves us with the alternative of a universe filled with matter in some form or other, this matter being completely in equilibrium, that is to say, its state remaining exactly the same without even the slightest change, until at some moment suddenly an event occurs. Matter being presumably not uniformly diffused throughout the universe, this would be contrary to the discontinuous nature of matter as we know it. It would have to be present in the form of one piece. For if there were more parts than one, they would move towards each other under the force of gravitation, and the universe would not be in a state of complete rest. The universe would have to consist of one tremendous lump of matter, having of course a temperature of 0 Kelvin, the absolute zero, because only at that temperature the particles may be considered to be at rest. Outside this lump of matter there would be nothing, no light, no radiation, only total emptiness. This first event would have to be completely uncaused. Obviously it would not have a proximate cause, as it was the first event which occurred, but it also could not have any fundamental causes. For if there had been a combination of factors which was sufficient to bring out that first event, this combination would have existed always, for the situation before that first event remained exactly the same. So there must have been some reason why this event occurred only when it did and not before. That is to say, there must have been a proximate cause. But proximate cause proved to be impossible, so the first event must obviously have been totally uncaused. There is absolutely no reason why this event occurred. Its occurrence is a complete mystery. For this reason, Zwart rejects this alternative. The possibility of an event occurring without the necessary and sufficient conditions for its occurrence is not very plausible, and such a picture of the universe is singularly unconvincing. Therefore, if the necessary and sufficient conditions for the occurrence of the first event did not exist from eternity, the first event would never occur. But if the necessary and sufficient conditions for the first event did exist from eternity, then the first event would have occurred from eternity. That is to say, there would have been no first event. Had the universe once been eternally and absolutely questioned, then it never would have awakened from its sleep of death. But since it obviously is not questioned, we may conclude that the finite temporal regress of events was not preceded by an eternal, absolutely questioned universe. Second, such a picture of the universe is at any rate empirically untenable, for an absolutely questioned universe would have to exist at the temperature of absolute zero, since heat is the result of motion, and there can be no motion in the universe which we envisage. But such a model of the universe is at once disqualified, since it is physically impossible to reach absolute zero. Quite simply, an absolutely questioned universe is physically impossible. There will always be some heat and some motion and hence some events. Moreover, matter existing in a state of self-collapse caused by gravitation would be anything but cold. It would be a volatile furnace with temperatures exceeding billions of degrees Kelvin, as in the Big Bang model. Hence, an absolutely questioned universe is doubly implausible. But even if such a state of absolute rest were attainable, how could a first event ever occur? Frozen into lifeless and absolute immobility, the universe would remain forever still, for no interactions of any sort could ever take place. An event would never occur, but events have occurred, and therefore we know that the universe never lay in such a state. Because an utterly immobile universe is empirically untenable on at least three grounds, we can conclude that the finite temporal regress of events was not preceded by an eternal, absolutely questioned universe. Therefore, we conclude the universe began to exist. And this is the second premise of our original syllogism, which we set out to prove. To recapitulate, since an actual infinite cannot exist and an infinite temporal regress of events is an actual infinite, we can be sure that an infinite temporal regress of events cannot exist. That is to say, the temporal regress of events is finite. If the temporal regress of events is finite, then either the universe began to exist or the final temporal regress of events was preceded by an eternal, absolutely questioned universe. But the finite temporal regress of events could not have been preceded by an eternal, absolutely questioned universe. Therefore, since the temporal regress of events is finite, the universe began to exist. Now that we've reviewed the second premise as well, let us go through scientific evidence for the beginning of the universe. The first scientific confirmation of the universe's beginning comes from the expansion of the universe. In 1917, Einstein applied his general theory of relativity to the universe, but he found that there was something terribly amiss. His equations described the universe which was either blowing up like a balloon or was collapsing in upon itself. During the 1920s, then, the Russian mathematician Alexander Friedman and the Belgian astronomer Georges Lemaitre took Einstein's equations at face value and came up with a model of an expanding universe. In 1929, the American astronomer Edwin Hubble made a startling discovery which verified Friedman and Lemaitre's theory. He found that the light from distant galaxies appears to be redder than expected. This red shift in the light was due to the stretching of light waves as the galaxies are moving away from us. This Friedman-Lemaitre model eventually came to be known as the Big Bang model and proposes that the universe is expanding, and as you trace the expansion of the universe back in time, everything gets closer and closer together. Eventually, the distance between any 2 points in space becomes zero. You've reached the boundary of space and time, and this is literally the beginning of space and time. The model implies that past time is finite and had a beginning. Since space-time is the arena in which all matter and energy exist, the beginning of space-time is also the beginning of all matter and energy. It's the beginning of the universe. The standard Big Bang model thus predicts an absolute beginning to the universe and serves as a major scientific confirmation of the second premise of this Kalam cosmological argument. In 2003, the Borde-Guth-Vilenkin model proposed that any universe which is in a state of cosmic expansion cannot have been infinite in the past, but must have a beginning. Secondly, there is actually a second scientific confirmation of the beginning of the universe. According to the second law of thermodynamics, unless energy is being fed into a system, this system will become increasingly disorderly. This provided a grim prediction for the future of the universe. Given enough time, all the energy in the universe will spread itself out evenly throughout the universe, reaching a state of equilibrium so that no life is possible. Scientists called this the heat death of the universe. This raises a question, however. If given enough time, the universe will inevitably stagnate in a state of heat death, then why, if it has existed forever, it is not now in a state of heat death? If in a finite amount of time the universe will reach equilibrium, then given infinite past time, it should by now already be in a state of equilibrium. But it's not. Therefore, the universe has not existed since eternity and had a beginning. Now, what is the nature of this cause of the beginning of the universe? It must be uncaused itself. It must be beginningless, timeless, spaceless, changeless, immaterial, powerful, and personal. It must be personal because of the theory of particularization. The existence of possible things in one time rather than another, or one place as opposed to another, is evidence of an external particularizer. Al-Baqillani argued that had the reason been inherent to the physical object in question, all such objects with identical properties would come about at the same time and place and in the same way. So the reason for something being the way it is and for coming into being at one time rather than sooner or later is proof of an external chooser, which is why the cause must be personal and must possess a will. This cause is God.